Hello guys, I wish and I hope that everyone is good and healthy. So myself Sudhanshu Sharma, and if I will talk about experiences that I have worked in Adobe, I have worked in IBM, I have worked in Western Digital and SanDisk. So today's agenda in this video that we will talk about the second chapter of the that we started in this video, that is hands-on on machine learning with Scikit-Learn and TensorFlow. So let's not waste our time and let's get started. Yeah, this is second chapter, end-to-end machine learning project. So we will go through what are the things that we will go through in this chapter. That is, look at the big picture, get the data, discover and visualize the data to gain insight, prepare the data for the machine learning and algorithm, select a model and train it, fine tune your model, present your solution, and launch, monitor and maintain your system. So working with the real data, it is good that you do your hands-on with the real data, so that you will have a more understanding and a better understanding, like how you are going to do with that. Everything is presented into that data, because now this world is full of data, and now we got the data, and what are we are going to do with the data to make it more usable? That is actually the machine learning is. So what it is saying in this, when you are learning about machine learning, it is best to actually experiment with the real data, like what I said. So it just telling you there are so many platforms that provide you the data learning sets, and data that you can get it from. So Kaggle dataset, Amazon AWS, and data portals, Open Data Monitor, Quandle, and there are so many places. But in this chapter, the author has taken the California housing price data set from the StatLib repository. This data set was based on the data from 1990 California census. It is not exactly recent, but it is not recent, but it has all the qualities which will help us to understand which will make understanding the model, so that it has all the attributes and categorical attributes, and some has been removed also, so it is good actually. And in this data, this is California housing prices, like this is latitude and longitude, like this is the place and what is the price of this thing. So let's come to the look at the big picture. So it is what the author is saying in this, like they have taken the California block data, and each block group in the California. So what it is saying, we will just call them a district for the shorts. So we have created a district in the whole California unit, and 600 to 3,000 people are there. 600 से 3,000 पीपल इसके अंदर हैं, तो उनको डिस्ट्रिक्ट बोल दिया है. तो इस प्रॉब्लम का क्या है कि इसमें प्रिडिक्ट करना है मीडियन हाउसिंग प्राइस इन एनी डिस्ट्रिक्ट, या जो मॉडल हम बनाने वाले हैं, द मॉडल दैट वी आर गोइंग टू क्रिएट, इट शुड लर्न and able to predict the median housing price in any district. Like for example, what it is saying, for let's say if you can see some small blocks are there, so they have just named it as a district. In this district, what will be the price of this, what will the median housing price of this. So this is, they have divided into the small districts. So it's टेलिंग अबाउट दो जो मॉडल हम बनाने वाले हैं, वो मतलब फ्रॉम द डेटा इट शुड बी एबल टू प्रेडिक्ट द मीडियन हाउसिंग प्राइस इन एनी डिस्ट्रिक्ट गिवन ऑल द अदर मैट्रिक्स. सो फ्रेम द प्रॉब्लम. फर्स्ट ऑफ ऑल यू हैव टू आस्क योर बॉस अबाउट द बिजनेस ऑब्जेक्टिव. So we have the data, and what we are going to do with the data, it's creating a model is not an end goal. Understanding the price of the district so that the boss can invest into that particular district, so that it gets maximum profit. So let's see in this, how does the company expect us to use and benefit from the model. This is important because it will determine how you frame the problem, what algorithm you will select, what performance measure you will use to evaluate your model, and how much effort you should spend tweaking it. Your boss answers that your model output will be fed to the another machine learning system along with many other signals. A piece of information fed to a machine learning is often called signals. So signals क्या होते हैं कि जैसे कुछ piece of information is given to the machine learning system so that it will be more understandable. So this is the downstream system will determine whether it is worth investing in a given area or not. Getting this right is critical as directed affects river revenue. Means we have to understand the data very clearly because it is going to affect our revenue. Because if we are investing in a bad house, then we will get a loss into that. The investment will be the waste. So machine learning pipeline for the real estate investment. So first of all, we have to understand what is a pipeline. Pipeline is a sequence of the data processing component is called a data pipeline. So if you can see it, some data upstream component is creating in district data and after that processing. So these are the pipelines actually. So how the things are going inside it and district data and district pricing. This is the component that we have created, district pricing and district price, and after that we are putting it into some signals as you can see it. Where investment analysis is going on, some other signals also we have added, or some other piece of information has been added to it, and after that the analyzing has been done by the model, and then the investment will be done. So let's understand the component will be done asynchronously. Each component pulls into this large amount of data, processes and spits out the result in another data store. So that's what I was saying. The upstream component is creating the data that we are processing it. It is getting into the district data, and after the processing is going to the another component, and after that component again it is processing it again, it is going to district prices, and then we are adding into the investment analysis for the analysis part, and the other signals has been also added, other piece of information has been added, and after the analyzing the investment has been processed. The next question to ask is what the current solution looks like. If it is often give you a reference performance as well as insight on how to solve the problem. Your boss answer the district housing prices are currently estimated manually by an expert. A team gather up to information about a district when they cannot get the median housing, they estimated using complex rules. So what it is saying in this, so if the people are not able to understand the median housing prices, they are analyzing other data and getting it by using a complex rules. मतलब समझ में मैं समझाता हूँ क्या हुआ कि जैसे मान लीजिए कि कुछ भी इंफॉर्मेशन वो पा नहीं पा रहे, जैसे इसका आई हैव अ वन टेबल एंड टेबल का अपन मैं लगा नहीं पा रहा हूँ कितना प्राइस है इसका. So what I will do, I will check to there are so many shops are there, and I will ask, okay, what is the price of this one? So I will get a lump sum price of the, not exact one, but the lump sum. So this is like complex, going to the each and every shop and understanding the price. This is a complex rule. So there are chances of the errors also, like it may contain error also, like for the example it is 15,000 price, but they are telling about the 12,000 and there's a difference of 3,000 in the prices. So this is a answer that district housing price are currently estimated manually by the expert. But the team gather up to date information about a district when they cannot get the median housing price. They estimated by using a complex rule. This is costly and time consuming, so their estimates are not great. In that case, where they manage to find the actual housing prices, they often realize that their estimate was of the 10%. So for example, that's what I was telling. They understood, actually they understood the pricing of the table was 15,000, but they are telling about the 12,000. So there is a difference of 20%, 20% into the pricing, difference of the 20%, but here it is a 10%, like 10% is the pricing error, that it should be it should be 15,000, but they are calculating as a 12,000. And it looks like a great database to exploit for the purpose. Since it includes the median housing price of the housing district as well, the okay with all the information, you are not ready to design your reinforce. So we will understand, okay, this is in previous video we have understood about the supervised learning and semi-supervised and reinforcement. So we will understand what kind of problem is this. So first you need to frame the problem. It is supervised, unsupervised, or reinforced, or which learning it is. It is a classification task, a regression task, or something else. Should you use a batch learning or an online learning technique? Before you read on, pause and try to understand this problem by yourself. So we have the data in supervised. What was the procedure? That we were provided with the labels and the properties and the properties of the, so that we can understand what is the price of it. So in the same has been given in this, that the median prices has been given, there are so many pricing has been given. For example, yeah, see, data has been such as population, median income. These are the property has been given. So these labels has been given. So it is a supervised learning. It is a supervised. Since you have found the answer, let's see. It is clearly typical supervised learning task since you are given a labeled training example. That's what I told you, that we are given with the labeled examples. Moreover, it is a typical regression task since you are asked to predict a value. We have to predict a value. More especially, this is a multivariate regression problem since the system will use multiple feature to make a prediction and predict. So this is all there is no continuous flow of coming in, there is no particular changing of data. So this is not a batch learning is not should. So plain batch learning should do fine, means there is no continuous, online is not required. So select a performance measure. So this is why we require it, root mean square error. Why we require it? We require because there is a error which we are getting it. Like for example, I told you like 10%. This is costly, and they often realize that the estimate were off by 10%. So the percentage is 10% off. So we try to minimize the root mean square error. So this is the formula. Let's annotation is there. So this equation, several very common machine learning notation that we use throughout this book. So what is AM here? AM is the number of the instance in the data you are measuring the RMSE on. For example, if you are calculating RMSE on the data set of 2000 districts, then AM is 2. If the districts are 2000, then the value is AM here, 2000 here, 2000 here. The summation is also here, that we are going to do the summation of it. Xi is the vector of all the feature values. For example, these are the values has been given. I will explain you this thing, like from where the values has been coming. I show you. For example, we just look at this data. This is the data of by the head we are getting. So these are the x values, total room, this. So this is the latitude, longitude and latitude and longitude. Okay, so housing median. So this is what we are taking the value of is. The same value has been used here. Like we have to create a matrices of it, like -18, 33, 1, 38, and we have to calculate the last one is 156 400. Here it is. For example, if the first district is the data set latitude is this, longitude is this, latitude is this, and it has an inhabitant with a median income of this one. So all the thing has been, and median value is this, and the median house value is this. Then this is how it will look. The median value is this. So X is a matrix containing all the feature value of all the instance in the data set. There is one row per instance, and ith row is equal to the transpose of xi, noted like transpose. You can see the transpose of this, and this is fourth one. The fourth, it is telling the recall that the transporter operator flips a column in vector with a row vector. See, here it is coming like this, and here it is transposing this one. So this is how it is coming. Okay, I know it is getting into very deep, but it's okay. We will try to understand it and understand like why it is required. So H is a system prediction hypothesis. When your system is given an instance, it outputs a value. So this is xi. So here the difference you see here is 2000. For example, if your system predict the median in the first district is this much, and the prediction error for this district is 2000, means there is a 2000 error is coming into the cost estimate measure example using a hypothesis H. We use lowercase the for and function names as lowercase bold font of X and uppercase font of matrices X. Even though RSM is generally preferred for font measuring for the regression task, in some context you may prefer to use another function. For example, suppose that there are many outlier districts. Both the RMSE and MAE have way to measure the distance between two vectors, the vector prediction and the vector of large targeted value. Various distance measure or norms are possible. Mean absolute error. This is also we calculate both, because the higher norm, because it focuses on large number, neglects small one. That's why RMSE is more sensitive to the outlier than the MAE. So actually this is the place like where we have to use a RMSE and where we have to use a MAE. तो यहाँ पे हमें ये समझना है कि कहाँ पे RMSE यूज़ करना है, कहाँ पे MAE यूज़ करना है. तो MAE का जहाँ पे ज़्यादा बड़ा डेटा होता है तो वहाँ पे अपन को ना स्मॉल वंस को हम इग्नोर करते हैं, तो इसलिए मोर सेंसिटिव रहता है. जो RMSE है ना, मोर सेंसिटिव रहता है दैन दी MAE, क्योंकि वो आउटलेयर पे डिपेंड करता है. ये RMSE जो है रूट मीन स्क्वायर एरर, तो ये आउटलेयर्स पे ज़्यादा डिपेंड करता है. तो अब क्या है, चेक द अजम्पशन. लास्टली इट इज़ गुड प्रैक्टिस टू लिस्ट एंड वेरीफाई द अजम्पशन दैट वी वर मेड सो फार. This you can catch serious issues only for the district pricing or output effect to nothing has been given here. Where the price is achieved, where the medium and expensive, that we will understand by the getting the data. Okay. Fortunately, after talking with the team in the charge of downstream, you can confirm that they do not indeed need the actual price, not just category, criteria, all the sets. Then now you can start with the data. Get the data. First of all, we have to get the data. First of all, you have to have the Python in your system, or it is telling about all the like have to get this Python in your system, or just you. So this is important thing. You will need a number of Python modules like Jupyter, NumPy, Pandas, Matplotlib, and Scikit-Learn. All the libraries you will need in this. If you already are running. If you have everything, then you have to just skip the parts, and if you don't have, then you have to install all these. So I will tell you the easiest way. Instead of going to install the each and every, just install the Anaconda into it in your system, and you are good to go. You just need to install. So if you are using MacBook, then otherwise it has already detected MacBook. So it is asking if your MacBook is a M1, M2, M3 with a chipset, then you install this. Then if your Intel is there, then install this one, Intel one. Okay. So I have already installed the Anaconda. So once you will install it, then that's how the Anaconda will look like. This is the window it will look like. all the environments learning community, data spell and Jupyter Lab, we will be using a notebook. So just click here and launch it. So this is how the window will open. It will run your Jupyter. I'll show you. Yeah, so if you can see it here, like dataset, this is how you can create with the Python. If you want to create a new file, Python, okay. If you want to rename it something, machine learning 1, rename it, okay. This is how your Jupyter will start. Now you have to just type everything here. For example, we have all the, see, if you remember that I told you initially that we are going to use the data from that HPL list, something is there. So we have taken a data from, it will download from the master, and after that housing path is there, and after that housing URL has been given. So it is creating a method here, the fetch housing data, that I will show you. This is how you just need to run with this. So that means it is already running without any problem. So I'll show you that one. Okay. So from here to there we have, yeah. So that's what I was telling you. Now we have a running Jupyter. You just need to create a Python 3 and just type a hello, print hello world. You can type it and looking for the hello word. It will print a Python with the hello word. Download the data. Yeah, this is the one. Here's a function to fetch the data. Import OS, import tar file from 6move, import URL lib. So here it has installed. This is the type line that we have typed. These are the lines we have typed. This is the method, which is what it is, fetching the housing data from this one. Here we have provided the housing URL, housing path. If not housing path, make directory, and it is taking from the TJZ path, housing path, URL lib, retrieve, and all this. So it will call you. When you call fetch, it will create a data set housing in your download the. You just need to call this one. Okay. You have to run it. Okay. So what it is saying, you can understand because it doesn't have OS. So it doesn't have OS. So we have to put this one, the tar file. Okay. Now, so I'll show you, like, import OS, import tar file 6, and here you are showing import pandas as well. And this here you are here just loading it, and here you have to show it. So in this method you have to show fetch housing data and housing data dot head. So if you run this one, see, all the data has been come. So this is what is happening inside here, like, okay. So this is importing the panda, and in this method what is happening, it is fetching the data. and here it is going to that particular file and reading it. Okay, after reading it has to show, right? So take a quick look at the data store. While just using a data frame head, you just use the method head, and you will get all the fields regarding the latitude and longitude. So they are latitude, longitude. Head will show you, see, 10 attributes are there, and matter, let's say top 5 rows of the data frame head. It gives you a top 5 rows, and all the things has been displayed here. After housing dot info, yeah. So it is saying that all the, by the info you will get the understanding what is the d type, data type, and all that. It is understand d type and what is a non-null. And the total bedroom only 20433. All the there are 0 to 20,006 in the 39 values are there. But in this all are non-null, but here you can see total bedroom, some nulls are there, so it has they ignored that null value. And in this also you can see the ocean proximity, the object is there. This is the object, and it is reading from the CSV file, then it is a text file, text data. So that we have to take care in object, because this is the object, we have to find it into the float one only, numeric one. So but it is coming as a, so that we will take care. Yeah, top 5 rows we have to check. That's what it is saying. There are 20,600 instances there, and proximity is a value count. So well, each category, by using a value count method, we can find out the category exists and how many districts are there. That we can understand it by using value count. You can use it all value counts, and by the housing describe also, and describe. Okay, yeah, this is important. Housing, I have a habit of, yeah. You can see the count is there, how many counts are there, and mean is there, standard deviation is also there, min is there, 25% is there, 55%, 50% is there, 75% is there, max is there. So yeah, I tell you, the field describe as show a summary of the numerical attributes. Okay, the count, mean, minimum, max are self-explanatory. You note that the null values are ignored, all the null values are ignored, that the total I showed you in that 20,433 not. The standard row shows the standard deviation, which means how dispersed the values are, and this is important. This is important. The 25%, 55%, 70%, 75% rows show the corresponding percentile. A percentile indicates the value below which a given percentage of observation in a group has been fall. For example, 25% of the district has median lower than the 18. Lower than 18. You can see it here, right? Lower than 18. 18, yeah. Median housing range is 25% has 25% of districts have housing median age lower than 18, while 50% are lower than 29, and 75% are lower than 37. Means it is saying what these are often called the 25% quartile, the median, and the 75% quartile. I'll show you what actually the quartile is. Yeah. For example, this is the value. 0 1 quarter 1 and quarter 3. This is the value, and this is, so this is quarter 1, this is quarter 1, this is quarter 2, this is quarter 3, like that. Okay, in this it is saying quarter 1, quarter 3, this is quarter 2. So for example, this is the value, this is the median is 0. So how maximum is this, how minimum is this? So how minimum the value of 3 sigma and minus 3 sigma. So this is actually the showing what are the distribution is happening. So this is quarter 1, this is quarter 2, this is quarter 3, like that. Quarter 1 values, this has been given like this, and quarter 2 has been given like this. So this is how the whole thing is, how the distribution, how the some value has been given. For example, 50% has been given. So how the correct value is 50% lower from this, and how the 50% higher from this, and 25% higher from this, lower from this, and 75% low, higher than this, lower than this. So this is like quartile. So yeah, quartile are the type of quantile which divide the number of data point into 4 parts. A quantile more or less or equal size. The data must be ordered from the smallest to the lowest. Such as quantile are a form of order static. The 3 quantile result in 4 data division are as follows. The first quantile is defined as 25%. Whether 20% of data is below this point. 25% of data is below this point. मतलब जो 25% है ना, इससे बिलो रहेंगे, और इसके ऐसे ही क्वारंटाइल सेकंड में रहेंगे. 50% इससे बिलो रहेंगे इस पॉइंट से, 75% से बिलो रहेंगे इससे. अपर क्वार्टर है 75% बिलो दिस पॉइंट. ओके, सो दिस इज व्हाट इज गिवन इन दिस. तो सेम यही एक्सप्लेन किया हुआ है यहाँ पे भी. तो 25% स्टोर हैव अ हाउसिंग मीडियन लोअर देन 18, 50% are lower than 29, 70% are lower than 37. These are often called 25 percentile median. Median is the 50th one, and the 75% is the third quartile. Quick way to get a feel of the data. You dealing with a plot histogram, and histogram also you can get a value of it. You just need to use this. Okay. See what we have done in this. Import matplotlib plot as plt, and here is a histogram is there. Hist method is there. You can use a figure size 20 by 15. If you can change the value, and you will see that how it affects. See, it got shrink, like 20 is correct. Like this is how, yeah, all are tail heavy. Okay, you can get a clear picture of this as a histogram also. So what else in this? So basically we have covered the half part of this, and in that we understood about the मतलब हम इसके बारे में समझें कि अपन कैसे पूरा व्यू पाएंगे उसका. यहाँ पे आपने देखा होगा अपन ने क्या क्या लाइब्रेरीज यूज़ करी हैं, क्या कौन कौन से मेथड यूज़ किए हैं. तो यहाँ पे आप इन सबको याद रखिएगा. So that will definitely help you, and we will go through in the second part of the second chapter in the next video. For the time being, please take care of yourself. Please share, subscribe, and watch this video with your friends so that it can help you. Thank you.